Hello everyone, my name is Griffin Kindred and this is my video on the XFLR5 project. Now I'm going to be doing the NACA 0012. I know my project partner Ryan Baker, he'll be doing the other one in his video. But so let's get to it. So we want to go to XFoil direct analysis. This is for the first part where we need to do the XFoil analysis. So we're going to go, we need our NACA. So in my case it's 0012. Number of panels is 100. Okay. Now what we need to do is we need to XFoil direct analysis. Oh, whoops. Okay, it's over here. And then define. So we have rentals of 100,000. That's what we wanted. Mox is going to stay 0. Everything should stay there. So for our analysis, we did -5 degrees to 20 degrees at a 0.5 increment as our angle of attack. And when we analyze, we will get our graphs just like this. Now to import, or excuse me, export these graphs, we're going to go to polars, current polar, export, and as you can see, here's my other ones. I'm just going to call this video airfoil. You need to save it as a .csv, so then in Excel we can open it. So to get our graphs that we're looking for, go to Excel, let's open what I just made, which is all files, of course. And then here is our video airfoil, and here we go. As you can see, we have alpha, CL, CD, just to show how to make it. Just gonna go to like there, insert, and I did a scatter. And as you can see, there's our CL versus alpha. Just title that CL versus alpha. There's our CL versus alpha graph. And if we want to do CD, we're gonna just hold Control, select all of those, and then insert table, and there it is. CD versus alpha. Anyway, so that is part 1. That's how we get our airfoils. I forgot to mention that we want to get our graphs, or excuse me, our if we want to get our lift slopes for this, I'm just going to run through it really quickly. As you can see, we go there. We want to add a trend line, even though we don't really need the trend line. We're just going to add our equation. And as you can see, 0.0523, that is our slope. So anyway, part 2, to get the wing analysis, what we're going to do is we are going to first we need to do a batch analysis. For this, I'm going to run it from 100,000 rentals to 1 million at a 20,000 increment, and we will analyze. And as you can see, it's going through every like scenario. All the graphs are kind of getting thicker and thicker. Takes a little bit. There we go. Okay, so now we will go to File, Wing and Plane Design. We will go to define a new plane. Oh, nope, excuse me. We need to go into this tab right here. Now we define a new plane. We'll call this video wing. We get rid of the elevator and fin because we don't need it for this project. We go to define. It's going to open a tab that looks like this. Now for our chord length, he wanted between 3 to 5 inches. So we chose 4 inches. 4 inches in meters is just 0.1 meters. And then for our lab, actually we got a chord length of 0.101. So that's what we're going to have, 0.101. That's our chord. And now, as you see, we have a V shape. So what we did was we just got rid of the offset. And I believe that is a good looking airfoil wing. So this should be pretty much our wing for the analysis. Oh, I'm so sorry, I forgot one thing, the most important thing. Oh, whoops. I forgot to make it. I was wondering why it wasn't 3D. Let's go back. Sorry, we go to define foil. I forgot to add the NACA, and since I'm already using it, it's already there. So we save that, save it. There we go. Okay, so now we have our NACA airfoil 0012, and this is the size that we actually used in the lab. So now what we need to do is go to define. So he wanted Reynolds number to be 100,000. I'm not sure if this is about, he wants this to be, because I couldn't figure out if I could change it. So at 14.9 meters, we found that the tip and root RE is 100,000. So the best way I was able to get convergence is with the ring vortex analysis method. So that's what I'm going to use. Hit save, and now we use this -5 to 20 at 0.5 interval. That's what we did for the last part. Analyze. As we can see, it's complete. We can go to our graphs here, and here is a very linear CL versus alpha and our CD versus alpha. And to get those graphs, we go to current graph, export graph. So this is, let's just say, video CL. Make sure it's a .csv. Save. We want to get the CD graph. We just right click the CD graph, current graph, export graph, and I'll just name it video CD. Save, and as you can see, it's as simple as that. We got some pretty good curves, and now the last thing we want to do is get our plots in Excel. So it's pretty much the same process as what we were doing for the first part. We just need to open them. So the first one I'm going to open is the CL graph, and I got to make sure it's all files. And whoops, I went too far. So here's our video CL, and if we just take that and we do the same thing, we add the table. As you can see, we have pretty much a linear graph. It's very easy to find the slope. Again, you just go to trend line, more options, display equation, and as you can see, our slope is 0.0422. So that's how you find your graph. We can change that, and we obviously will add titles. This is just how to do it. I'm just trying to do this as quick as possible to save the viewer the time. And then for the next part, let's just show the CD graph. So video CD, same thing, just hold and click all the plot points, insert little scatter graph here, and as you can see, we got a nice little CD over alpha. Obviously we can rename that, we can add the titles there, we don't need the slope. And we will add all this to the report, and that is how to do the XFLR5 Project 1. Thank you for listening and watching, and have a good rest of your day.